Hello everyone, welcome to IB Math Solution. Today we will be studying complement of a set. So before studying complement, we need to know a concept about universal set. What is a universal set? Universal set is a set which contains all the elements of that type. So what do we mean? Let's suppose we have to find the elements digits used in writing whole numbers. So what are the digits used in writing whole numbers? We know 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the digits that are used in writing whole numbers. Firstly, universal set is denoted by U. So when we say digits used in writing whole numbers, then what we mean is U is equal to a set containing 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. This is a universal set in this context. Now, moving on to complement of a set, set A. So when we say set complement of a set A, we denote a complement by A prime. A prime is the complement set of set A. Now let's say A, let A be a set of even numbers. So that will be 0, 2, 4, 6 and 8. It has to be a subset of U and it has to contain all the even numbers. So these are the even numbers. So A will look like this. Then A complement will contain all the elements of U that are not present in A. So A prime will be 1, 3, 5, 7 and 9. So what did we learn? A and A prime together make a universal set. So we can write it in a statement that a set A and its complement A prime combine to make a universal set. So from here we have three conditions. Let's say when A and A prime are complement sets, then condition 1, A intersection A prime must be an empty set. A union A prime must be a universal set. And third, number of elements in A plus number of elements in A prime must be equal to number of elements in A union A prime. So when we say A and A prime are complement sets, then these three conditions must satisfy. Let's solve some questions from exercise 2C. So the question says, let U be a set containing 1, 2, 3, 4, 5, 6, 7, 8, and 9. Find the complement of A. So when we know A is a set containing 2, 3, 6, 7, and 8. So A prime or A complement will be a set from U, will be a subset from U not equal to the elements of A. So 1 is not present in A, so 1 will be an element, 2 will not be an element, 3 won't be an element, 4, yes, 4 is not present in A, 5 not present in A, so 6 is present in A, 7 is present in A, 8 is present in A. So A complement is this, and this is our answer. Part B says, if P is a set of prime numbers, is P prime or P complement a set of composite numbers? If yes or if no, explain your answer. So we know universal set is this. Now P is equal to a set containing prime numbers. So what are the prime numbers from this set? That will be 2, 3, 5, and 7. Now, what is P complement or P prime? The elements of U that are not present in P. That will be 1, 2, 3 are here, 4, 5 is here, 6, 7 is here, 8, and 9. Now, the question is asking, is this P prime a set of composite numbers? So we know this is a composite number, 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 but 1 is neither prime nor composite. So from here we can say no, P complement of P prime is not a set of composite numbers. And in explanation, because 1 is neither prime nor composite. Let's move on to the next question. The universal set, let U be a set containing months of the year. So U will be January, February, March, April, May, June, July, August, September, October, November, and December. So this is our universal set. Now part A says M is a set containing months starting with J. So M will be a set containing months that start with J. That will be January, June, and July. So M prime or M complement will be February, March, April, May, August, September, October, November, and December. This is for part A. Now part B says A, set A contains months containing the letter A. So what are the months that contain letter A? January contains, yes. Feb contains, March contains, April contains, May contains, June does not, July does not, August contains, September does not, October does not, November does not, and December does not. So these are the months that contain letter A in them. Set A will be January, February, March, April, May, and August. Now, A complement or A prime will be June, July, September, October, November, and December. That is our answer. Let's move on to the next question. Let U be a set containing whole numbers between 10 and 20 inclusive. So U, universal set, is a set of numbers between 10 and 20 both inclusive. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Part A says list the elements of A. Now what is A? We know A is a set of factors of 120. So what are the factors of 120 that are between 10 and 20 inclusive? That will be 10, 12, 15, and 20. Part B, the elements of B. What is B? B is a set of multiples of 3. So the multiples of 3 between 10 and 20 inclusive are 12, 15, and 18. Now part C says complement of A or A prime. The complement of A will be the elements of U that are not present in A. So what are those elements? We can see 10 is present, 12 is present, 15 is present, and 20 is present. So A complement will be 11, a set of 11, 13, 14, 16, 17, 18, and 19. Part D says B prime or B complement. So B complement will be, first we need to find the elements that are present in B from U. So 12 is present, 15 is present, and 18 is present. So apart from that, apart from those three elements, what are the elements that are in U? 10, 11, 13, 14, 16, 17, 19, and 20. This is our answer. Now part E is asking A intersection B. So what is A intersection B? So A intersection B will be the common elements that are present in A and B both. So that is 12 and 15. A intersection B is 12 and 15. F is A union B. A union B is a set of all elements of A and B. So what is A? 10, 12, 15, 20, and from B we already have 12, we already have 15, 18 is remaining. So this is A union B. Now G. G is asking A complement intersection B. So A complement is this one and B is this one. So we have, what are the common elements in A prime and B? 12 we do not have here, 15 we do not have here, and 18, only 18 is present. So A prime intersection B is 18. A prime union B. A prime union B will be a set containing 12, 15, 18, 11, 13, 14, 16, 17, 18 we already have, and 19. Part I says A intersection B prime. A intersection B prime. So A intersection B prime is, this is A, this is A, this is B prime. Now we have to find elements from these two sets. What are the common elements? 10 is present in both, 12 is not here, 15 is not here, 20 is present in both. So 10 and 20 is the answer. Part J. A union B prime. A union B prime. So we have got to consider these two sets A and B prime, and then write the terms, all the terms, 10, 12, 15, 20, 10 we have already taken, 11, 13, 14, 16, 17, and 19. 20 we have already taken. So part K is A complement intersection B complement, or A prime intersection B prime. Now we know A prime is this one and B prime is this one. So what is the common part? 11, yes. 13, yes. 14, yes. 16, yes. 17, yes. 18, no. And 19. So 11, 13, 14, 16, 17, and 19. Similarly, L part, A prime union B prime, that will be, this is A prime, this is B prime. So the union will be 11, 13, 14, 16, 17, 18, 19, 10, and 20. So this is our answer. Let's move on to the next question. Suppose universal set U is this here, A is this one, and B is this one. Find number of elements in U. 1, 2, 3, 4, 5, 6, 7. That will be 7. Part 2 is number of elements in A. That will be 3. Part 3 is number of elements in A complement. So the number of elements in A complement will be number of elements in universal set minus number of elements in A. That will be 7 minus 3, that is 4. So where we have got this formula from? This formula, we know when A and A prime are complement sets, then number of elements in A plus number of elements in A prime is equal to number of elements in universal set. So part 4 is number of elements in B. That will be 4, and part 5 is number of elements in B prime. That will be number of elements in universal set minus number of elements in B. That is 7 minus 4 or 3. That is our answer. Part B says copy and complete. For any set S within a universal set, number of terms in S plus number of terms in S prime is equal to, so number of terms in S plus number of terms in S prime or S complement is equal to number of terms in the universal set, or number of terms in S union S prime. This is our answer. Let's move on to the next question. So here in question 5 says, suppose P and Q prime are subsets of U. Number of elements in U is 15, number of elements in P is 6, number of elements in Q prime is 4. Find the number of elements in P prime. So we can say number of elements in P prime is equal to number of elements in universal set minus number of elements in P. That will be 15 minus 6, that will be 9. Part B says number of elements in Q. So number of elements in Q will be number of elements in the universal set minus number of elements in Q prime. That will be 15 minus 4, that is 11. That's it for this exercise. I'll see you in the next session.